Last two tests of infinite series. Talia, I just hit record and you're already off task.
No, because I covered up with this new paper.
Oh yeah, it is. It's on that podium. Ratio and root test. Now, if you learn something from Khan more than I'm saying, or maybe an insight, share with me because I'm not too old to learn. Last two tests. We're going to do the ratio. We're going to do the root test. Then there's a review in here. Well, it's not really a review. He just gives you like another little chart that I've given you already, like 4 of them. Ratio test. The rule for the ratio test is really quite simple. You have a sequence, or a series, A sub n. And we're talking about the limit of A sub n as n goes to infinity. So we're adding up a bunch of terms, right? We're not actually adding, we're doing the sum, we're doing the sum. We're adding them all up. And we use a limit often because we're not talking about when n is 1 or n is 2. We're talking about when n is like near infinity, like a billion gazillion, right? We really care what's happening in the future. Does it converge? Does it diverge? And let the sum of A sub n series be non-zero terms. Well, that's kind of like common sense. Can't have zeros. Number 1, if the series converges absolutely, you can check it by doing the absolute value of A sub n plus 1 over A sub n. Remember what A sub n is? Since you're going to infinity, n is approaching infinity, A sub n means the one in the future.
Yes.
Right? So we just should call it A sub n. But what happens if I say A n plus 1? What does that mean? The one afterwards. Right? N plus 1. So it's infinity plus 1, which is still infinity. It's kind of silly, I know. But we're talking about 2 terms. Maybe it could be the 7th term and the 8th term, or the 9th term and the 10th term, or the 1,000,000th term and the 1,000,001th term. 1,000,001th, is that a number? The 1,000,001st term? I don't know. 1,000,001 term probably doesn't have a TH. So it's just a limit. And what you do is you rewrite your sequence or series symbolic. Okay, and we'll practice that in a second. And the thing about it is, if you do this ratio, the one that is in the future over the one that's behind it, if you do that ratio and you do the absolute value of it and you get less than 1, we know it converges absolutely. If you do the same ratio and you get greater than 1, which he says, or you get infinity, hello, infinity is bigger than 1, so that's like duh. We know it diverges. Now, this might be the very first test that said, what happens if you get like exactly a 1? It means we don't know. Does that mean you're done? No, it means the test doesn't work. You have to use a different test. And you say, oh my God, I just did 4 tests. Now you just did 5. That didn't work, so now you got to find a 6th test. Okay? So I tried picking some of different kinds. Here's your first one. The sum, as n starts at 0, and it didn't matter. He could have started at 1. It really doesn't matter. And there's my 2 to the n over n factorial. So how am I going to check this?
With the ratio test or the other one?
Ratio. That's the limit as n goes to where? Infinity. And is this my A sub n or is this my A sub n plus 1? A sub n. Does that go to the bottom or the top?
Bottom.
That goes to the bottom, so 2 to the n over n factorial. What will I put on top? 2 to the n plus 1 over n plus 1 factorial. And we take the absolute value. Now, when you do this, I kind of ignore the absolute value because I do some scratch work and I do this on my paper. I do 2 to the n plus 1 over n plus 1 factorial, and I multiply it by the reciprocal of the bottom fraction, n factorial over 2 to the n. Now you have to ask yourself, how does this cancel things out? Now maybe you figured it out. Well, I got a secret for you. Notice 2 to the n plus 1 can be written as 2 to the n times 2 to the 1. Because what's the rule when you multiply like bases? You add the exponent. So I broke it apart just for fun. And the bottom here, n plus 1 factorial. Believe it or not, n plus 1 comes after n, right? So why don't I take the last term out, n plus 1, multiplied by n factorial. Wouldn't that account for everything from n plus 1 factorial? Because here, I'll show it to you. Remember what n plus 1 factorial is? It's n plus 1 times, take 1 away from n plus 1, n times, take 1 away again, take 1 away from n, n minus 1, take 1 away from n minus 1, and it keeps on going, right? Well, what if I just take the n plus 1 and take all of this and call this n factorial? That's what I did right there. To me, when I first had to teach this many, many years ago, nobody ever did this stuff with me in high school. Well, I wasn't invited to calculus. But even in college, I don't really recall doing n factorial stuff. I was like, wow, that is really like black magic. And it took me a long time for it to sink in. So let me erase this so I have more room. Now that you agree with me that I can rewrite that, what do you think I'm going to do with the this fraction right here? Yeah, that's the beauty of this. The n factorial does cancel out. How about the 2 to the n?
It becomes 2 to 1.
Oh my God. So I'm going to rewrite this now as the limit as n goes to infinity of, she said it's a 2 to the 1 over n plus 1. Don't forget the absolute value. And now, is it safe to plug in infinity? What do you get?
You get 0.
Oh, because 2 divided by infinity is always going to be 0. 1 pizza divided by 1,000 of Adam's friends means Adam gets no pizza. Sadly. Well, he gets the last bite. Ew. So that gives you 0. Oh my God, what did the rule say about 0? Is that bad or is that good? Why? Oh, 0 is less than 1, so a sub n converges. Converges more than that. Converges absolutely. That wasn't too bad, was it? The hard part was this right here, Talia. Knowing how to break these things apart. Once you break those apart, things cancel. Life happens. Okay? And let's see if his...
It converges.
Yes, because it's less than 1. Okay? So, let's try another. What did he do here? He said, you could look at the graph of a sub n.
Are we going to need a calculator for the quiz?
No, because we're not graphing. We're doing tests. Okay?
Okay.
So, look at when he graphed each term, he did a sub 1, a sub 2, a sub 3, a sub 4. And as he did all these terms, what does it look like it's happening? What's happening there?
It's converting.
To something, right? I don't know what it's turning into, but I don't care, do you? We're not saying where does it converge to. We're just saying it looks like it's converging. He did 15 terms, and it does look like it converges. So in other words, what if Talia did have a calculator and she graphed them? Sometimes if it's a multiple choice section with calculator, Go ahead and graph it. If you can't figure out what test to use, take a look at it. Try to graph the function and look at where it is at A when 1 and 2 and 3, and you can see it. Here's another one.
Right.
Yes?
I think in the multiple choice part, there will be like questions like, here, this is the function, what test would you use to see if it converges with X?
Yeah, I have seen that before.
Yeah?
I have seen that.
And so we have to decide which.
Yeah. And hopefully he gives you a couple stupid tests that don't seem like it would work, you know. Like he says alternating series test, and it doesn't even have a -1 to the n power, right? So then you know it's not alternating series. Okay, tell me about this problem. What's it look like?
The inverse
Not the inverse. Wrong word.
is, well,
Does it look like example 1?
yeah.
Example what? It's reciprocal. So just take a guess. What do you think happens? Because you saw what happened a minute ago. We had a number over infinity.
So it's gonna be infinity.
We're probably going to get what?
Infinity.
Over a number. So the answer to this should be what?
Infinity.
Should be, well, that's not the answer. The answer is, does it converge or diverge?
Divergence.
Diverges. So it's going to be the same work. Do I have to really do it? It's still going to be the limit as n goes to infinity of the absolute value of an n plus 1 times an n factorial. That was the, right, over 2 to the n plus 1 times. I have it reversed, don't I? Oh, no, I'm okay. I think 2 to the n, and what was the other one? 2 to the n and n factorial? Something like that. And this 2 to the n is the same thing, 2 to the n times 2. So the 2 to the n cancels out, the n factorial cancels out. Now you plug in infinity, you get infinity plus 1 is infinity over what? What's left on the bottom? A 2. And that equals to infinity, right? So we say diverges. Sometimes you got to actually say by the ratio test, because right now we're not saying it because that's the only test we're using. But when you're doing a free response problem, you want to tell the author what you're using. It's all worked out on the next. The PowerPoint was better because each of these was a drop-down box, but because Sandy wanted me to record. All right, another one, ratio test. Yes, sir. Yes, sir. You're missing out on a nice problem, but that's okay. So he's telling me to use the ratio test. What test do you think you might have tried first if you weren't told?
Alternating test?
You might have looked at the alternating series because it has that switch.
Yeah.
But sometimes more than one test works.
How do you know not to use the alternating but use the
You don't. Unfortunately, sometimes, and I was talking to somebody yesterday, you could do 4 or 5 tests before you find one that works. And even if you use the flow chart, it may or may not, it leads you, but you're checking all these things. It's like a puzzle. When you get it right for the right test, you kind of feel like, wow, I'm good. All right, so let's do the ratio test, which will mean that I'm going to do the limit as n goes to infinity. Absolute value, what goes on top? Do I care about the -1 to the n power?
No.
Why not? Absolute value. So I don't really care about that part. What's left on top? A 1. Because if you're going to absolute value, it doesn't really matter. Over the n plus 1 over the 1 over the n. I think I wrote it right. Was it a sub n plus 1 over a sub n?
Is
Is-
a n plus 1 over a sub n.
I got it right? Okay. So that turns into, I'll keep it in the absolute value just for fun, goes to infinity of the absolute value of 1 over n plus 1 times the reciprocal, n over 1, equals to the limit as n goes to infinity of 1 times n is n over n plus 1 times 1 is n plus 1. How do I do that limit? You've had that before, Adam. You've had that before. What happens if you plug in infinity and n at the top? Tell me, Adam.
Infinity at the top?
Yeah. If n goes to infinity, what's n become?
Infinity?
Thank you. And Gilbert, if I plug infinity in the bottom, infinity plus 1 is how much? Infinity. And what is infinity over infinity?
1.
No.
Oh, no.
It might be 1. I'm not saying the answer may not be 1. But what are you supposed to do when you get infinity over infinity when you do a limit? L'Hopital's rule. This is indeterminate. You're supposed to say something like, that goes to infinity, that goes to infinity, so that's indeterminate. Now, he may not show that in the notes. You know why? Because this is not notes for an AP class. This is notes for a college class. So they don't get picky. But your AP readers need to know, what are you doing here to evaluate that limit? And now you're going to say equals to, by L'Hopital's rule, by L'Hopital's rule, this is the limit as n goes to infinity of the absolute value of, what's the derivative of the top? What's the derivative of the bottom, Talia? What's the derivative of n plus 1?
You take the one, well, that's gonna be done.
That 1 will be gone. What's the derivative of n? What's the number in front?
1 and then
1. So that answer is
1.
1. What does that mean?
Oh, okay, so if it's less than 0, it converges. But if it's greater, it diverges?
Is that greater than 1?
No, it still converges.
Is that less than 1?
Oh, no.
Is it greater than 1?
Uh-uh.
What's the third thing if it equals to 1?
Oh, it's the one with the I, right?
Yeah.
And, well, I don't know, but I know it starts with an I.
Help her out, Maran.
Intermediate? No,
Inconclusive.
Inconclusive, okay, that.
Or you don't have to use those fancy words. If I was doing the AP test, I can't even spell inconclusive, so I'm going to probably say, oh, this test fails to tell me anything.
Okay.
The test fails. So then you're supposed to do something else.
Okay, but I got that.
Yeah.
Use another test.
Huh?
Use another.
You'd have to use another test, so maybe that's when I would have used the alternating series test. A lot of people jump to the ratio test because it's easy. It's easy. You know, as long as it's a fraction. They like it. A lot of people like it. I don't know if he did another test. Let's see. Because this didn't come from the textbook. I just found this problem. And let's see. Equals to 1. The ratio test. We cannot use the ratio test to determine. He didn't use the inconclusive word, Talia. And this was a guy who's an expert. We would have to use another test. Oh, look at this. In this case, the alternating series test would be a good choice. So maybe you would have used the alternating series first and now. Who's to say what's better?
Mr. Carter,
Yeah.
before the quiz, we make like a little review of each
Oh, yeah.
Well, I think it's in your notes here.
It's here.
Yeah, I hope so. Plus, you have those flow charts with all the stuff.
Are we allowed to use it?
Oh, of course you can. Yeah. All right. Hopefully, I have time for you guys to do it. If not, I'm going to ask you to do it and send me your answers by tomorrow so I can use it as a grade if I don't get done. All right. How would I? Okay, I'm going to use ratio test. So I'm going to do the limit as n approaches infinity of what goes on top, Talia?
1.
No.
No, and then.
I got to add 1 to both ends.
Oh.
N plus 1.
Sorry, I never got that part.
Well, you're just adding 1 to n.
And then,
So I, What-
Basically, you substitute n plus 1 for n.
I substitute what?
n plus 1.
For n.
Everywhere you see n, you turn it into an n plus 1.
Oh, okay.
So the bottom of this part becomes e to the what?
And e to the n.
And then the bottom fraction is exactly the same fraction.
Okay.
N over e to the n. And then by the power of magic fractions, you didn't realize that calculus really has power. That we can take the top fraction, n plus 1 over e to the n plus 1, multiplied by the reciprocal, e to the n over n. And the only thing I see that I can do, the n plus 1 and the n, they don't cancel nothing out because, but look at the e to the n plus 1. Believe it or not, you can rename that. Now, you guys that are really good, you probably won't write it out, but I'm going to write it out because I'm not you. I'm going to write e to the n plus 1 as e to the n times e to the 1. You see that? And I'm going to write the second fraction as plain e to the n over n. And lo and behold, what did I notice?
Cancels out.
What does?
E to the n.
Oh my gosh, you're a genius.
Wow.
Now, all I have left, Talia, is n plus 1 over n.
Well, don't
Eh.
forget your E.
Oh, and my e, which is a constant. That could be important. You're right. So,
Okay, I kind of get it. I get it.
okay, so what happens when I plug in infinity into n plus 1?
Indeterminate.
What does it give me? It gives me infinity. What about e to the 1 times infinity?
Indeterminate.
It is indeterminate. It's infinity over infinity again. So by L'Hopital's rule, limit as n goes to infinity. Let me do the derivative of n plus 1. Derivative of n plus 1. Adam, come on. Oh, Gilbert, you gave him the answer.
1?
Yeah. You did that on your own, or did you hear him?
No, I didn't hear
Yeah, you don't need him. 1 over. What's the derivative of e to the 1 times n? It's the same thing as if I say 3x. What's the derivative of 3x? 3. This is the same thing as a number times x. What's the derivative? E to the 1. How big is 1 over e? Small?
Yeah.
Would it be smaller than 1?
Yes.
Yeah, because, well, how big is e? 2.7. So this is 1 over 2.7. Round it to 3. 1 over 3. Is that bigger than 1 or less than 1?
Nice.
Less than 1. So what does it do, Talia?
It's less than 1,
Yeah,
so it's convergent.
it certainly does. Yay!
And
I didn't keep no n.
oh, I mean you still multiply. You didn't cancel it out with it.
Oh, I was looking at n plus 1 over n. I kept it here. They didn't cancel out. So then I plugged in the infinity. So I had an infinity plus 1 over e to the 1 times infinity. See that?
Then we just keep the end.
Okay.
Yeah, well, keep the what? All right, and look at our solution looks exactly like his solution. All right, root test. Root test is the easiest test in the world to ever do. It's just you got to know why would you use it, okay? Root test has the same rules as ratio. It's why they put them together all the time. When you do the root test, all you're doing is taking the nth root of your series, of your a sub n. And he also put absolute value because why? Why does he have absolute value here?
Because
You don't know if that's an even or odd root. N could be a 4, n could be a 6. And you can't take the square root of a negative number. So to make it safe, they write the absolute value. So again, the switch gets written off if you have one. If you do the nth root, which really means, I hope you understand, that it really means a to the n is raised to a power of 1 to the n. That's the same thing as nth root of a to the n. A of n, a sub n. So anyway, if you get less than 1, it converges absolutely. And the reason it's absolutely because you are using the absolute value. If it's greater than 1 or it's infinity, it diverges. And if it's equal to 1, it's inconclusive again. And when you see the problems that, unless I missed something, no, less than 1 converges. Greater than 1 diverges. Diverge applies to, you can't help but thinking, root test, root test. The reason is, look at my exponents. The exponent has an n in it. So if you take e to the 2n and you raise it to 1 over n, what's 2n times 1 over n? Because that power to a power, what cancels out?
The N.
The n's cancel out. So that's why we will use the root test when you see powers of n. So I'm going to write the limit as n goes to infinity of e to the 2n,
Less
oh,
one.
hold on here, n to the n, all of this raised to the 1 over n.
So we don't do the plus one anymore?
No, this doesn't have a plus 1. This has, I could have done this.
Ratio has plus one, but
Yes,
this one.
I could have wrote it like this, nth root of the whole thing. But which means the same thing as, raise them both to the 1 over n. And the reason I'm going to do that, oh yeah, I didn't write it, you know why?
Because it's possible.
E to the 2 to the n is always going to be a positive number as you go to the right. And n to the n will always be positive as you go to the right. N to the first, n to the second, n to the third will always be positive to the right. I didn't write it, but a lot of people still would write it just because. But I don't have to write it if I know it's never negative. It's already positive, but feel free to write it. Limit as n goes to infinity. I'm going to write all the steps. Once you get good, you won't write all the steps. E to the 2n times 1 over n. That's what happens here, right? Over n to the n times 1 over n. That power gets n times 1 to the n. You see this, Talia? When you raise a power to a power, you multiply those two powers.
Okay. Okay, I see that.
Equals to the limit as n goes to infinity. If you go 2n times 1 over n, what does that turn into? E to the 2. The bottom turns into just a plain n. What's e squared? Is that a variable or a constant? And what's infinity in the bottom? This is the same thing as Adam's pizza. Goes to 0. What does this one do? It's less than 1, so it does what? Diverges.
But I just don't get that.
What part?
When you multiply the, like, 2n,
Power to a power.
yeah.
When you have 6 squared raised to the fourth power, the rule is you multiply those powers together.
So it'd be,
6 to the 8.
but then how does that work?
Say it again.
But then how does that work with the n?
It's the same thing. I started out with e to the 2n. That's a power raised to the 1 over n.
So you multiply that?
So I multiply those 2n times 1 over n. That's what I wrote right here.
So it's, oh, okay, so then it'd be
2n over n.
over 1
Yes.
over n?
Yes.
And then, like,
The n's canceled.
okay, yeah, I get it.
Okay.
Mr. Carr,
Yes.
isn't it, so it's backwards from the ratio, if it's less than 1, it
No.
diverges?
No, I don't think so. Wrong symbol.
Yeah, yeah.
0 is less than, oh, why did I do that for? I was even thinking of Talia, thinking that she said, oh, less than 1 converges. I don't know why I wrote that. I'll blame it on the drugs. My eyes are full of drugs today.
You still have pink eye?
Yeah, I don't know what they're calling it, conjunctivitis, and they just haven't, conjunctivitis?
That is like pink eye, no?
Well, pink eye is generic for all of it.
Yeah.
So we're not really sure. They tried 3 medicines. I started getting a little bit of relief, but I'm telling you the truth. The medicine that Dr. Lugo put in my eye this morning, it was at lunchtime, and I was thinking, wow, I feel better right now.
Yeah.
Yeah, so I'm still worrying a little bit, but
How did it all start?
It's like
I don't really know, and they don't know. I was here at school last week. What day?
Sir, can I go to the restroom real quick before you?
Yes. I think it was. Oh, it was Monday. And I was here, and I felt like I had an eyelash in my eye, and I didn't know what it was, and I rubbed it. You're not supposed to rub your eye, and I was, what in the world's going on? And by the time I got home, my wife said, "Wow, what's wrong with your eye?" I don't know. And so I decided the next day, that was going to be Wednesday. I said, "Oh wait, yeah, Wednesday." I went to the doctor, and he gave me drops, and I asked if I could go to school. My phone, and it's from Lynchburg, Virginia. You know who it is? It's Liberty University Liberty University, they want me to apply. Because you click one button on the internet and they keep calling you to. They do it too, the other schools? You just click one button to look, see what programs they have, and they got you forever. Yeah. Take a hint. You've called me 10 times and I've not returned a call. You know. All right.
So
Yes.
did they see an eyelash in there? Or
No, they didn't see anything, and they said it could be something that blew in my eye, could be that somebody had something on their hands, I touched them, and I touched my eyes, but I don't recall touching my eye. But I remembered I did get hit outside with the bougainvillea bush, a stick.
Oh, that's so cool.
But can that cause an infection that could travel to both eyes?
Well, maybe like there was some type of dust or something.
Yeah, like pollen or something?
Yeah.
Some pollen or something, and that got in your eye.
I got hit like 2 days before that, taking out the garbage, racing my wife around the car, and I didn't see her branch, and it hit me, but it didn't hurt me. I don't remember, like,
Maybe there was like something like they kept.
yeah, so
And then it just stayed there.
just did. The e to the 2n over n to the n just stayed there. What this guy did, he decided the problem, he grafted as well, and he did 10 terms, the 50th term, and look what you see happening. Do you see any evidence of convergence?
No.
No. 386, 386, 386. It's the same number.
Isn't that convergence?
That's what I said.
Oh.
Do you see any evidence of converging?
Yes.
Yeah. Now, I don't know what the 5th decimal and the 10th decimal was, but the 3 decimals from 50 to 100 terms to 500 terms was converging. So that's interesting. All right, another one, another root test. How do I recognize that would be a good candidate of a root test?
It looks like it.
You got an n power, right? So let's do it. Try to race me through it. See if you can do it instead of just waiting for me. Limit as n goes to infinity of n to the n raised to the 1 over n over 3 to the 1 plus 2n raised to the 1 over n. And yes, just to make Camilla happy, I will absolute value it. Actually, the absolute value goes... Actually, the absolute value is actually on the inside. It's not really on the outside of that. But duh, if it's that, it's going to be the other one too. All right, so tell me, equals limit as n goes to infinity. What is n to the n raised to the 1 over n?
And
You sure?
Yes.
Okay. What is 3 to the 1 plus 2n raised to the n?
1 over n plus 2.
What?
Yeah, it's 1 over n plus 2 because 2 and...
Oh, you broke it up into 2 fractions.
Oh, yeah.
3 to the what? 1 over n plus 2?
Yes.
That is so weird. You could probably play with that if you wanted to, but I don't think you have to. What happens if I plug in infinity now? What do you get? Infinity in the top. What's 1 over infinity?
Infinity.
No.
Oh, no.
It's Adam's pizza shared with 100 of his friends. 0. What's 0 plus 2?
2.
Oh, that becomes 3 to the 2.
Oh, I thought you meant that.
Mr. Cartwright,
Yes.
wouldn't it be infinity over a small number because it's 1 over n?
Oh, no, I'm not. I'm just talking about this 3 to the 1 over n plus
Talk
2.
about the 1 over
Just this part.
Exactly.
Well, I'm not done yet. I'm just doing this part. Isn't this still turn into a 3 squared?
Yes.
Doesn't this turn into 3 squared?
So yeah, but no.
Okay, so that turns into infinity over 9, doesn't it?
No.
Why not? On the top is in,
Because this infinite root of 3 isn't going to be a very small number.
infinite root of 3. I don't have an infinite root of
But
3.
doesn't it look like this? Wait, can I have it?
You have 3 to the 1 over n plus 2.
Wouldn't it look like this? 9 infinity 3?
No.
Because that's 1 over n, right?
No, this goes together. This goes together. That's one exponent.
Oh, I get you now.
Okay.
1 over n.
So this turns into infinity over 9. What's infinity over 9?
Infinity over
Infinity.
Still infinity. So what does that mean?
infinity.
diverges by the root test. Let's see if I answer there. Divergent. Yep, look at same answer.
That reminds me of the book.
I always feel so good when I get it right.
You said divergent, and it reminded me of the book.
Yeah, or the movie.
Where have you seen
Us intellectual people don't read the books.
it? What do you want me to don't read the books? I always read the books.
I know.
Wait, Mr. Carter, so your eye doesn't hurt? Like,
Yeah, it hurts like heck.
oh,
Does it,
really?
you wanna itch it?
I want to, but it's not as bad as it was. I only came to school yesterday today to make sure I came to school at least once for A day and once for B day.
That's nice.
I did it for you, but I'm not coming tomorrow.
That is okay.
But the medicine is.
But Mr. Carter, you have enough days to.
I have 110 days, but no, but see, but I can't do that. I feel so guilty not to be with you.
Well,
But you're
you
pretty
do.
good at staying on top of your stuff, like,
Yeah.
some teachers just take days off and go.
Don't even give you anything to do, right?
Yeah,
I can't do that.
yeah.
Because my mind, I think I want you to pass the AP test and get an A in this course more than some of you want to.
Oh,
I sometimes think that's true for a lot of my students, that I care more about their end result than they actually do.
That just means you're a really good teacher.
Well, I like to believe so. I tell my wife when she says, stay home. I said, no, I can't. They need me. And she looked at me and she goes, they don't care if you don't go. And you know what? I go, yeah, you're probably right for most of the kids. But deep down inside, I have to believe or else I just quit teaching. Somebody cares if I'm here.
When are you gonna retire? Cause
Dan Gilbert?
no, I'm saying
Wow.
this 'cause you're never gonna like.
No, I already have it in my mind that
Okay, yeah,
I was going to go
like
2 more years.
I was like, you're not gonna.
No. I know I don't want to keep, I'm I'm tired.
But you're gonna go 2 more
2 years.
22.
Unless something happens to me, yeah. Unless I decide that I've had enough or I get another job.
Why 2 years?
Because then I'll have that magic number called 90.
90.
It means if you take a couple of numbers and add them up, it adds up to 90. You have to have an 80 number to retire. Has to do with your experience and age and all that.
And what
So,
does 90 mean?
well, 90 allows me to get cash advance out of retirement.
Wait, what?
If I wanted to take out, like, I could retire and say I want to have 3 years of my highest income paid to me up front. And they could give me $160,000.
So I worked for 80 years. Oh wait, more than 80 years, and I
You'll
get.
only be 11.
Well, it's not really working 80. It's also combined with, it's a formula that uses your age.
I see.
Yeah, so it's like Mr. Who's the Spanish teacher? He if he retired today, his paycheck would be exactly what he's getting right now for the rest of his life.
Period.
He's working for free, except for insurance. You know,
If you retire, you don't get insurance anymore.
you got to pay for it.
Oh, yeah.
So he would make the same if he didn't go to school?
Yes, he would. And I asked him that, why are you here? And he goes, what would I do if I stayed home? Let me count the things I could be doing.
You could be watching The Bachelor. Just kidding.
I would.
Oh, let's not go there.
Oh, sir, did you finish watching?
Stupid show.
Oh, Mr. Carter.
I can't believe it. Every single time, never anybody gets committed. Oh, I think I love the other girl. I love Hannah Ann more.
I'm still single.
It was just like,
I'm never watching it again.
no.
That can't be real, though. I feel like they make the
No, you
drama.
know what you need to watch this?
Yeah.
This would make you believe in love again.
Love
Love
Island?
is Blind. No.
Oh.
It's on Netflix. It's like,
Oh, I have.
Days.
Yeah, I've seen that before. I have seen Love is Blind, yeah.
So good.
Now, the thing is, I think they just get on there and they go through this emotion just to get famous and be on, quote, a member of the Bachelor Nation. So they could be on Bachelor in Paradise or something.
No, but I thought Maddie was
When she
really
comes
good. Like, why didn't he? It was just so dumb. Like, he said he really liked her. Then why did he keep the other girl there? Like,
Well, we know why.
Right?
His mother.
wait, no. Because he still, after the day that he was her, she told her, like, oh, like, if you were to get down on one knee,
Can you-
like, I would say yes, right?
Yeah.
And then he went on the date with the other girl the next day, and it was like, what?
Can you believe what Sandy right now is listening to this saying, what the heck are they
No,
talking
and
about?
he said, he's like, my heart is with Maddie.
All right.
So then he went on a date with
Moving
her.
on.
It makes lots of sense. Huh?
Do you still?
Why would a root test be perfect for this?
we don't talk about it.
Why is the root test perfect for this one?
Because of the end.
N power. So limit as n goes to infinity
Hey,
of
What is that? Oh, okay.
of all of this and
Crazy.
nth root of all of this to the end. What do you think happens? What happens if you raise this whole thing 1 to the n?
Oh,
It cancels.
Oh, you
out
take
the
out that
end.
thing.
Yeah, it cancels.
So then,
Yeah.
So Christina left because she said, I'm not staying in here if we're going to talk about Bachelor. So this turns into, ma'am,
Converges to TV.
say it again?
If when you retire, you might just be able to watch telly on TV.
Oh, yeah.
If anybody was to get on TV, it would be her.
Yeah.
Yeah.
So can I plug in infinity now?
Yes.
Hey, what's the trick if the powers were the same?
Then you cancel
it's
out.
it's
Or you
use the
divide all the
coefficients.
things.
You could take those leading coefficients.
So 4.
The answer's 4.
So then it's like
Greater than
divergence.
1 diverges. Yes,
Are you, okay.
you bet.
That's it.
Yeah. Yep, there it is. All right. Do I want to do another one? I'm kind of tired. But let's see what's next. Because I got to this one. All right. If I let me write it out. Limit. What are you doing, Talia? Oh, tissues.
There.
No, a girl used them all up, but you can use that right now, and I'll get another box.
Okay. Where's the other box? I can get it.
No, I don't. I don't have it handy. Limit as n goes. So that's the 2 to the n plus 1 raised to the n raised to the 1 over n, right?
Yeah.
Right? And this is n to the 2n raised to the 1 over n.
So you make it so complicated.
I know, because
After spring break, we just have Easter break.
I'm sure that some people need to see the detail. It's a problem is you guys are already 3 steps ahead. And actually, I did too many problems. I did too many because I think you guys got the point. But this turns into 2n plus 1 over what? Just an n squared. That's right. So what happens now when I plug in infinity?
It's 2 over infinity.
It's 2 over infinity, which is what?
That's a 0.
0, which means what?
It's
Convergence. It's right. 0. Yeah, it was 0, which converges. All right, hold on. Oh, I love this one too. Oh, I love this problem. That's okay. I don't know.
Wait,
Yeah,
what?
things happen.
Why did we?
No, I couldn't get my computer to give me a fraction, so I had to write it like this. It's actually 1 plus 1 over n raised. Yeah, it's formatted weird. So if you do the the root test again, you're going to cancel out this power up here, right?
So you skip just skip it on purpose.
Huh?
You skipped one of the problems.
You were there. Here's this one. I just jumped to the gun and said, what happens when I raise it to the, if I'm doing the nth root of all this, I'm left with what?
1 plus 1.
Say it again?
It was 0.
Yeah, it was. The answer was, the last one here is, that turns into 1 plus 1 over n. What does that do?
It becomes 1.
No, becomes 1, thank you. Becomes 1,
Wait.
which means what?
That's because 1 over n
Oh, 1
to
plus
the
0,
infinity
yeah.
is 1.
So what does that mean?
It's
Converge?
inclusive.
I think
Inconclusive. We don't know. The test failed to tell us anything. So you'd have to do a different test. Maybe the integral test, maybe
Do root test.
the root test failed. We just did the root test. It didn't
I
work.
meant the ratio test.
I would use the ratio test
Try
next.
Can we try it?
Knock yourself out.
Great.
Oh, you're asking me strategies for testing series. As always, guidelines for testing a series for convergence or divergence. Does the nth term approach 0? That's the first thing we learned in this set. If it does, then we automatically it diverges. That's a good one to always do. Does the limit of the nth term equal 0? If it does, you're done.
And if it doesn't, you have to use one of the other.
Then you got to keep trying. Is there a series of special? Can you tell if it's geometric? That's usually geometric is the one before the next one. You can be written as a fraction, and you keep
Wait.
writing the same
So
fraction.
it'd be 1 and then plus plus 1 over 2.
Could be.
That you mean that? Like
Yes, you see, so check that out and check it out. Those are also called P-series. If you just say P series would be 1
over something.
over,
N to the power of something.
yeah, the power is changing. I mean, the base is changing. 2 squared, 3 squared,
Wait, the base?
4 squared, yeah, the power stays the same, but
Oh.
the number itself is changing. Then you can always do the integral test. And let's see, he gave you a nice list. Let me give you the paper for these. I got you a paper of these. Those are your problems.
Right.
Yes.
Do you have a extra flow chart? I forgot my.
I'd have to see if there's any laying around, but I was getting rid of stuff. I mean, I have them, I just don't have more copies.
I was just,
All right.
using it yesterday, so I forgot my desk at home.
Put one in at a desk.
You
All right.
guys coming back?
You guys can talk this out. Do this together.
Sorry, I didn't get one.
Because she didn't want to pass it. She said, I'm not giving it to him.
Yeah, no.
Can I get one, sir?
Well, I gave it to her too, and she didn't want to give it to
Can I
you
get
either.
mine?
So funny.
Talk it out.
Is this a quiz?
Yes, this is it.
Are you doing right?
It's so hard.
Can we solve it right here?
Go ahead, yeah. Talk about it.
Oh, this one's the one we just talked about, right?
For A,
Yeah, we could.
Is it 1 over
it's
2?
1 over 3.
Right? Yeah.
Wait. Hold on. What's 1 over 3?
Limit of N approaching infinity.
But, okay, when you do that test, that's called the nth term test. That only tests for divergence.
Yes, but if it's 1 over 3, then it's converging. Wait, no.
That doesn't mean that.
Wait, I don't even know.
If
Less than 1, it's convergent.
no, you haven't applied a test yet. She's just doing the nth term test. That's a test for divergence. That doesn't tell you if it converges.
Wait, what?
The nth term test is the limit.
And she's using that one?
She did.
Isn't that only if it equals to 0?
If it equals to 0, you know it diverges. If it doesn't equal to 0, the test failed.
Okay, I'm gonna do G because that's the one we've been doing.
Isn't G inconclusive?
I don't know.
That's why you use a different test.
You're going to have to use a different test for A. Nth term test didn't work. G, let's see. Nth term test, I would probably use the root test.
I think
Yeah.
G, right?
I would use the root test for G. You bet.